Welcome back to RamZland. Today I want to use green food coloring to demonstrate the immiscibility of salt water and isopropyl alcohol. Check this out. For this experiment, I'm using 50 milliliters of distilled water, 50 milliliters of 91% isopropyl alcohol. I'm using potassium carbonate, and I'm using green food coloring. This white background is so you can see the color shift, and I'll use this density bottle to illustrate why the food coloring changes into yellow and blue at the end. The first step is to add your water to your isopropyl alcohol. And remember, the isopropyl alcohol is miscible in water. That means it will dissolve in water. Then add just a drop of green food coloring, put on a stopper, and mix the solution until you have a nice homogenized green solution. Next, measure close to 13 grams of your potassium carbonate. And now we're going to add our potassium carbonate. And now watch the color change. Look at that. A bright yellow on the bottom and a blue on top. So at this point, you can definitely see the bottom half has turned yellow and the top half has turned blue. How is that possible? So what's going on here? We've got this blue on yellow that came from green food coloring. Is this immiscibility or is it magic? Well, this is really a miscibility demonstration. That word, it kind of sounds like solubility, where if I have a solid solute and it dissolves in a liquid solvent, then I would say it's soluble. Well, what if the solute and the solvent are both liquids? That's where we use the term miscibility. So in this case, one liquid, isopropyl alcohol, is immiscible. It does not dissolve in my salt solution that was made with potassium carbonate and water. So in this demonstration, the one that's least dense is going to float on the top. This is the alcohol, the isopropyl alcohol solution. And the one that's more dense is going to be at the bottom. This is my salt solution. But why does it change color? Well, green food coloring is really made of two dyes. You've got both blue and yellow dye, and it appears that the blue dye is more miscible in the alcohol solution, whereas the yellow dye seems to be more miscible in the salt solution. And I like to use this density bottle demonstration for this. I have two layers here. This layer, you can guess, is the alcohol solution. This layer down here is the salt solution. But when I mix up all of these beads, you can see it separate rather dramatically, because although the beads look like they're exactly the same, they aren't. One is a little bit more dense than the other. You can see the white beads are coming down, and you can see all the blue beads are on the bottom, but only for a moment they start to rise. And down here, it's separating the salt solution from the alcohol solution up here. The beads that have less density are on the top. The beads that are slightly more dense are on the bottom. But here again, it's an example of miscibility. I have alcohol, which is non-polar, and I have salt water, which is a polar molecule here on the bottom. Pretty cool. What I love about this is how the color changes from green to blue and yellow. Such a dramatic demonstration. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.